Hello and welcome to Cashmatics. This is the second lesson in a series on straight line graphs. And in this lesson, I'll be talking about the most popular form of the equation of a straight line, which is y equals mx plus c. Now we're going to start by looking at the results of an experiment, so to say, and analyze our findings and draw conclusions. And hopefully by the end of the video, your understanding of y equals mx plus c will be greater and you'll be able to answer questions more successfully. So grab yourselves a pen and some paper and let's get started. Now the equation of a graph tells you the relationship between the x-coordinate and the y-coordinate. Now whether it's a straight line, a circle, a curve or a wave, it makes no difference. The x-coordinate and the y-coordinate are linked by the equation. So let's say we had the equation y equals 3x. What that means is to work out the y-coordinate, it's 3 multiplied by the x-coordinate. So if these are the x-coordinates we pick, now you can pick any numbers, but I've chosen to pick the numbers between 0 and 5. I'm going to work out what the corresponding y-coordinates would have been. So all I'm going to do is multiply each of these numbers by 3. So 0 times 3 is 0, 1 times 3 is 3, then I get 6, 9, 12 and 15. And if I wanted to plot any of these points, I look at the x value and the corresponding y value, so 5 and 15 in this case, and I would plot that over here, so 5 across, 15 up. So this orange line here is the line of the equation y equals 3x. And we've also got y equals x, y equals 2x, and y equals 4x. And as you can see, these lines are getting steeper and steeper, and the mathematical name for the steepness of a line is its gradient. So let's make an observation here. The fewer the number of x's, the less steep the line, or the shallower the gradient. And the more number of x's an equation has, the steeper the line. So what we can conclude from that is, the more x's an equation has, the steeper the line is going to be. Now let's have a look at these lines on the right hand side. Now before we analyze them, I'm just going to fill in a table of values for one of these. Okay, so we'll do the one for y equals 2x plus 6. So that means the y coordinate is 2 times the x coordinate plus 6. So 2 times 0 is 0, plus 6 is 6. 2 times 1 is 2, plus 6 is 8. And if you carry on through, you'll get these coordinates. Okay, so for example, this one here, that would be 5, 16, which is that point there. Now let's see what we can determine from these lines. First of all, they've all got the same gradient. Okay, all the lines are parallel, and it follows on from last time that if they've got the same gradient, they'll have the same number of x's. Okay, so that's what we saw over here. Okay, the number of x's tells us the gradient, so we can see that rule is working here. But they've also got a different point at which they hit the y-axis. Okay, so although the lines are parallel, they're not in the same position. This top line hits at 6, and we can see this equation has a plus 6. The next one hits at 2, and this has a plus 2. This one hits at 0, and in fact I've got a plus 0 here, which I just don't bother writing. And this one hits at minus 4, and I've got a minus 4 in the equation. So what we can say is, the part of the equation with the x tells us how steep the line is, and the other part, which is added or subtracted, is the part which tells us where it crosses the y-axis. Okay, and where the y equals mx plus c comes from is y equals mx plus c. So this number here with the m tells us what the gradient is, so the steepness of the line, and the c tells us what the y-intercept is. So make some notes from that page there, and then we'll move on. Right, so we're going to move on to negative gradients. Okay, and hopefully this will demonstrate the difference between a negative gradient and a positive gradient. Now we've got two equations over here which are very similar. The only difference being this one's got a minus 2x and that one's got a 2x. And we're going to see the difference that makes. So let's just fill in these table of values. Now I've got to be really careful now because I've got negative numbers over here, and over in the equation here I've got a negative 2 as well. So I've got to be extra careful to make sure I'm applying my rules for negative numbers. But let's just go through it. 2 times x, so 2 times minus 3 is minus 6, plus 3 is minus 3. 2 times minus 2 is minus 4, plus 3 is minus 1. 2 times minus 1 is minus 2, plus 3 is 1. 2 times 0 is 0, plus 3 is 3. And if you carry on, so 2 times 1 is 2, plus 3 is 5. You'll get 7 and 9. Okay, the positive numbers are easy. Hopefully you'll get those. Let's do these ones over here. I've got to be super careful now because I've got a negative multiplied by a negative again. So minus 2 times minus 3 is minus 6. So minus 2 times minus 3 is 6. I nearly made a mistake. Nearly made the mistake myself. And 6 plus 3 is 9. Minus 2 times minus 2 is 4. 4 plus 3 is 7. Minus 1 times minus 2 is 2. Plus 3 is 5. Minus 2 times 0 is 0. Plus 3 is 3. Minus 2 times 1 is minus 2. Plus 3 is 1. Minus 2 times 2 is minus 4. Plus 3 is minus 1. And then minus 2 times 3 is minus 6. Plus 3 is minus 3. Okay, so those are my tables of values. And what we're going to do is we're going to plot those. So there we go. Those are the two lines. Okay, so we've got y equals minus 2x plus 3. Sorry, let me just correct that. And y equals 2x plus 3. Now both lines are very similar. Okay, they've both got a very similar gradient. Okay, they're just as steep as each other. They're just pointing in different directions. And this point here, the plus 3, is identical for both. And the reason for that is we've got a plus 3 here and a plus 3 here. So the difference a minus 2x makes is it makes the graph point in a different direction. So a negative gradient will make the graph go down from left to right, and a positive gradient, in the case of the blue line, so a 2x, will make the graph go up from left to right. So what we can conclude from that is, if the number with the x is negative, this will make the line slope downwards from left to right, and if it's positive, it'll make it go up from left to right. So make a note of whatever you've learned from that screen, and then we'll move on. Now before we move on, I'm going to explain in a bit more detail what is actually meant by the gradient. So what I want you to do is consider one of these squares. Okay, so when I'm talking about one square, I'm talking about one of those squares, and hopefully you can see that on this grid. Now the definition of the gradient is every time you increase x by 1, so to increase x by 1 you'd go one square in that direction. The gradient is how many squares you'd have to go up or down to get back to the line. So in this case I'd have to go up 2 squares to get back to the line, and that's why that line's got a gradient of 2. Now if you notice this line is actually sloping downwards, so if I increase x by 1, so remember x always increases in that direction, so from left to right, so that's gone up by 1, I actually have to go down 3 squares to get back to the line. And you know, as the coordinate axis suggests, the positive directions are up and right, the negative directions are left and down, so down would be minus 3, and that's why I've got a gradient of minus 3. And this last one, if I go across 1 square, so if the x increases by 1, to get back up to the line, I'd only have to go up half a square, and that's the reason why the gradient there is a half. So hopefully that's helped you to understand what gradient means. Now this is where your understanding is really going to be tested. Now what you've got there is 5 sets of axes, and on those axes you've got a red line and a blue line. And underneath each set of axes, you've got 4 equations, and you need to match up the red line with the right equation and the blue line with the right equation. And that means 2 of the equations in each of those sets just wouldn't be valid. So you've got to deduce which ones match the red line, which ones match the blue line, and which ones just don't work. So just remember, the number of x's tells you how steep it is. The other number tells you where it crosses the y-axis. Now there's no scale on these axes, so all you've got to decide is it crossing somewhere positive or is it crossing somewhere negative. Alright, so pause the video, give it a go, really think it through, and you should be able to get this if you've understood what we've been talking about. But as always, I'll go through the answers. So pause the video now and I'll go through the answers. Right, so let's have a look at this first set. Now, the easiest line to consider here is the red line. We can see the red line is crossing at the origin. Okay, so right there. So we know there's not going to be a number at the end. And the only one without a number on the end is that one there. So that's got to be the red line. Okay. Now, because the blue line is parallel to the red line, we can eliminate anything that doesn't have a 2x. So this is y equals 3x plus 2. So we can get rid of that because it needs to have the same number of x's to be parallel. And we can get rid of this one as well because that's got a 3x in it. So this one here is the blue line. And look, the plus 5 works as well because that's crossing somewhere positive. Right, this next one, both lines are crossing at the same point, and that point is something positive. So the plus something or this at the end needs to be a positive number. It can't be a minus something. Okay, so anything with a minus something, so this one here and this one here, we can cross those out. Okay, so let's cross those two out. Now, let's have a look at what else is going on. The blue line is steeper than the red line, which means the blue line has to have more x's. So this one here must be the blue line, and this one here must be the red line. Okay, they've both got a plus 1, so they both cross at the same point, but the blue line is steeper than the red line. Now in this next one, we can see the blue line is steeper than the red line, which means the blue line has to have more x's than the red one. So these equations, some have 2x, some have 3x, which means the blue one has to be one of the ones with a 3x, and the red one has to be one of the ones with a 2x. But there's still things we need to think about. Now the red line crosses somewhere higher than the blue line. Okay, so the plus something on the red line will be bigger than the plus something on the blue line. So let's have a look what that can be. This one's a plus 4, okay, and this blue one's a plus 4 as well. So that means this can't be the blue one, otherwise it would have crossed at the same point. Okay, so I can get rid of that. And which means this can't be the red one, because the blue one has to cross at plus 2, and that one was a plus 2. Okay, the blue one has to cross somewhere lower than the red one, so now we've got the right two equations. Moving on to the next one, they both cross at the same point, okay, and that has to be a positive point, so the y equals mx plus c, the plus something needs to be a positive number, not a negative number. Okay, so I can eliminate these two because they're both negative. Alright, and now I just need to pick the right gradient. The red line is pointing downwards from left to right, so it's going to have a negative gradient, so it's got to be that one. That's got a minus 2x, and this one here has got to be the positive one. And this last one, although it looks a bit tricky, it shouldn't be too bad, because all we need to look at is the blue line to begin with. Okay, the blue line's got a positive gradient, and it has to have a positive intercept. So let's look at which one's a positive. That one, and that's the only one. Okay, positive gradient, positive intercept. So that's fine, that must be the blue one. Now the red one has to have a negative gradient with a negative intercept. Okay, so all of these have got negative gradients, but only one of them's got a negative intercept, which is this one here. So that there is the red line, so we can get rid of that one there and that one there. And if you've got all of those right, that really shows you've understood this topic well. Now before we move on to the last exercise, we're just going to recap y equals mx plus c again. So that's the standard equation of a straight line. The m, so the number with the x, tells you what the gradient is, and the c tells you what the y-intercept is. Now sometimes people can get muddled up, especially if you have something like y equals x plus 2. They don't see a number there, so they think the gradient is 0. But in fact, the gradient is the number of x's. Okay, so that's the gradient here would be 1. Okay, so the gradient would equal 1. Okay, and the y-intercept would be 0, 2. Sometimes it's written in a way which can be confusing for some people. Okay, so people sometimes automatically assume the first number is the one with the gradient and the second one's the y-intercept, but no, it's a number that's with the x, which is the gradient. And what makes this doubly confusing is because people might think it's a 3 for the gradient, but it's actually a minus 3. The number of x's is minus 3x, so the gradient is equal to minus 3, and the y-intercept is 4. The other thing you might get is something like this, 2y equals 3x plus 7. Okay, now for this rule to work, for that to be the gradient and that to be the intercept, it has to be in the form y equals mx plus c, but this is 2y. So I'd have to divide by 2. So what you do is you just divide each term by 2. Okay, and I like to leave things as fractions. So my gradient is the number with the x. So the gradient is 3 over 2, and the y-intercept is 0, 7 over 2. And finally, sometimes you might get something like this, 3x plus 4y equals 17, for example. Now, this is nowhere near in this form, so I need to rearrange it. So I would subtract 3x, so 4y equals 17, take away 3x. Then I'd divide by 4 to get that. So my gradient would equal the number with the x, so minus 3/4. And my y-intercept would be 0, 17 over 4. Right, so here we go. This is the final task. I've got the equations on the left. All I want you to do is extract what the gradient is, what the y-intercept is, and which direction the line is going in. So let me just explain this first one. Y equals 2x plus 5. That isn't the correct form. Y equals mx plus c, so no rearranging required. So the gradient is the number with the x, so that would be 2. The y-intercept is this number here, so 0, 5, so give it as a coordinate. And the direction of the line just means will it point upwards, downwards, or do something else. So this is a positive gradient, so it'll point upwards. Now there are some which which will do something that you'll have to actually think about. Okay, and when you get to those, you'll find out. So just remember, if it's not in the form y equals mx plus c, then you need to rearrange it and think carefully about what the gradient is and what the y-intercept is. And pause the video, and I'll go through the answer shortly. Right, so I'm about to go through the answers, so if you didn't pause the video, please pause it now. Otherwise, major spoilers. Right, this first one, that's in the correct form. The gradient is 6, that's the number with the x, and the y-intercept is 0 minus 3. That's a positive gradient, so it'd go upwards. This one here, the gradient is the number with the x, it'll be minus 2. The y-intercept is the other number, so 0, 7. And that's a negative gradient, so it'll go down. This one here needs to be rearranged, so I'm just going to do it over here. So I divide everything by 3 to get y equals 5x over 3 take away 8. So my gradient is 5/3. So this would be 8 over 3, sorry. The gradient would be 5/3, and the y-intercept would be 0 minus 8 over 3. Just remember, you have to divide everything by 3. That's the mistake I just made over there. I've still got a positive gradient, so it's still going to point upwards. This one here, I need to rearrange it in 2 steps. So subtract 2x to get 3y equals 7 take away 2x. Divide by 3 to get 7 over 2 take away 2x over 3. And pick out the gradient, so minus 2/3. And the y-intercept is 0, 7 over 2. That's a negative gradient, so it's going to point downwards. Now these last two might have bamboozled you a little bit, but hopefully you'll recognize that these are the equations of horizontal and vertical lines. So x equals minus 2 is a vertical line, and y equals 4 is a horizontal line. Now the y-intercept for x equals minus 2. Now if you imagine that's the axes, x equals minus 2 will do something like that. It's never going to reach the axes, okay, so that's not applicable, okay. And the gradient is actually infinite, and I'll explain in a bit why it's infinite. That's a bad infinity symbol. Let's do a better one. Okay, that's better. For y equals 4, so let's just do that. Okay, y equals 4 would be there. That's actually got a gradient of 0, and I'll explain that as well. And the y-intercept, well, that does cross the y-axis, it crosses at 4. So if you've got all those right, brilliant. If you've got the majority right, but you didn't understand the last two, I'll explain in a moment why the gradients are what they are for those two. So if you remember from before, the definition of the gradient is if you go across one square, so if x increases by 1, how many squares would you have to move up or down to get back to the line? In this case, it'd be 2. So the gradient here would equal a positive 2. Okay. Now, if I've got a horizontal line, if I go across one square, the number of squares I have to go up or down to get back to the line is 0. Okay, I don't have to go up or down to get back to the line. I'll always be on the line if I move across one square, which is why the gradient of a horizontal line is 0. But for a vertical line, the moment I leave that line and go across, no matter how far up or down I go, okay, I'll never be able to get to the line. I could go up and down to infinity, and I'll never get back to the line. Okay, which is why the gradient of a vertical line is infinite. Anyway, I hope that video has helped you to understand a little bit more about y equals mx plus c. Now, you're almost guaranteed to get a test on this, so it's really important that you go over it quite regularly so you don't forget everything you've learned. And in the next video, what we're going to do is we're going to look at another form of the equation of a straight line, which is ax plus by equals c. And that type of form is used quite often when it comes to solving simultaneous equations, linear simultaneous equations, and also when you want to graphically find the solution, the questions are often presented in that form. It won't take you long to learn that. It'll be a nice short video, but it'll also be very valuable for when we do graphing when we start graphing inequalities as well. Anyway, that's all for now. I hope that's helped, and goodbye.